Welcome to the AgroInsure project, an ECVET-compliant training initiative for transforming industrial urban surfaces into thriving green agricultural spaces. This is a training video developed in the framework of the project. In this session we will have a demonstration of simulation scenario 3, which you can find on the project's learning management system. The scenario is provided as part of the ECVET-compliant curriculum designed to support sustainable agricultural practices on industrial and urban surfaces. The scenario's title is Load-Bearing Capacity Calculation, and it is mainly a structural feasibility assessment for rooftop farming. If you are an aspiring rooftop farmer, you need to assess before you plant and ensure your building can carry the future of urban agriculture. In this webinar, users will learn how to use the load-bearing capacity calculation tool to assess if their building can safely support a green roof. Users will gain practical insights to support informed planning decisions before starting their projects. Users need to remember that this tool only offers a preliminary assessment, and they must consult experts in the field before proceeding with any construction. Let's go. Welcome to this tutorial on using the simulation scenarios within the AgroInsure platform. At the top navigation bar of the AgroInsure platform, you'll find various navigation buttons. To access the simulation scenarios, click on the simulation scenarios title. Upon clicking this button, you'll be redirected to the scenarios page, where you can explore and choose from 3 available scenarios. You can either select a scenario by choosing the appropriate scenario from the drop-down menu on the top navigation bar, or by clicking the highlighted Here button below each scenario. In this tutorial, we will focus on simulation scenario 3. Simulation scenario 3 is designed to calculate the load-bearing capacity. This scenario provides essential information about the basic evaluation process for installing a rooftop farm facility on a reinforced concrete building. However, please note that the results of this simulation should not be used for an actual project implementation. Users must consult professionals to assess the inputs and results before proceeding with any construction. Let's get started. We will have a step-by-step look at the parameters considered in this simulation, which will be used to evaluate the feasibility of a rooftop farm. 1. Seismicity of the region. The seismicity of the region is a crucial factor, as it influences the level of lateral load acting on the structure. Using the drop-down menu, you can select from 3 risk levels: low, moderate, and high. For this tutorial, we will choose moderate risk. 2. Age of the building. The age of the building is important because construction materials degrade over time, losing their mechanical properties. In the drop-down menu, there are 4 options available. For this example, we will assume that the building is less than 10 years old. 3. Shape of the building. Next, we specify the shape of the building for the rooftop farm installation. There are 5 options available, and we will choose rectangle, as it is a common building shape. 4. Floor plan dimensions. Now, we enter the floor plan dimensions, both horizontal and vertical. For the horizontal length we will select 15 meters, while for the vertical length, and since the building is rectangular, we will also go with 15 meters. 5. Spans in horizontal and vertical directions. The span represents the number of beams in both X and Y directions located between columns. We choose 5 beams for both the horizontal and vertical span. 6. Height of the structure. Next, we specify the height of the building. There are 6 options to choose from, and we will go with less than 11 meters. Additionally, we need to enter the total number of stories in the building. Based on specific requirements, the selected height, less than 11 meters, corresponds to 3 stories. Clicking the green Table Here link, users are redirected to a table that verifies this information. 7. Number of columns. Now, we enter the number of columns present in the building's floor plan. For this example, we will input 20 columns. 8. Cross-section area of a typical column. The cross-section area of a typical column must be a positive number with decimal points separated using a dot. We enter 0.5 square meters. 9. Additional axially load-bearing elements. If the building includes shear walls or masonry load-bearing walls, we need to input their cross-section area. In this case, we will enter 0 square meters. Now that all fields have been completed, We click the Next button to initiate the calculation process, which will then redirect us to the Calculations and Recommendations page. On the Calculations and Recommendations page, we can review the results based on the provided inputs. The first calculation determines the approximate floor plan area. Based on our inputs, this has been calculated to 675 square meters, confirming the total available surface area of the rooftop for potential use. Next, the simulation calculates the approximate structural weight, which in our scenario is 30,375 kilonewtons, kN. The remaining rooftop farm weight capacity has been determined to be 54,625 knots. This means the structure can safely support the additional 30,375 knots of load on the rooftop. However, if the remaining weight capacity was negative, this would indicate that the structure is unable to support the specified load. The simulation also assesses the approximate axial load capacity utilized by static loads in the structure. This has been calculated to 15%, meaning that 15% of the total axial load-bearing capacity of the columns is currently being used to support the existing structure and its static loads. Consequently, 85% of the axial capacity remains available. The final calculation evaluates the penalty points related to the seismic design of the structure. In our case, the result is 19 out of 100, which is considered a strong score. Now that all data related to the simulation scenario have been entered, we can proceed with submission. Based on the provided inputs and calculated values, the structure has been deemed suitable for rooftop farm installation. Additionally, it is clearly stated that the weight of the farming facility should not exceed 80.93 knots per square meter or 54,625 knots in total. At this stage, there is an option to download a report generated from the provided information and calculated results. By pressing the Download Report button, a PDF report will be created with the title, Structural Seismic Report, Basic Evaluation for Installation of a Rooftop Farm Facility. The report consists of 4 sections, each presenting key details. 1. The Seismic Structural Input section outlines the seismic and structural parameters, including the appropriate seismic risk level for the region, which was set to moderate based on the data entered. Additionally, this section presents the building's age and shape. 2. The Floor Plan Dimensions section details the floor plan dimensions, specifying a horizontal length of 15 meters and a vertical length of 15 meters. 3. The Structural Load Details section provides information related to the structural and load parameters, including the number of spans, which are 5 horizontally and 5 vertically, the building height which is set to less than 11 meters. The number of stories which is 3, the number of columns which is 20, the cross-section area of columns which is 0.5 square meters and the axial load-bearing cross-section area which is 0.4. The Calculated Structural Values Seismic Risk Assessment section presents the calculated structural values, along with a color-coded assessment, green, yellow, red, indicating whether the results are good, average, or poor. For our example, the approximate floor plan area is 675 square meters, the approximate structural weight is 30,375 knots, the remaining rooftop farm weight capacity is 54,625 knots, the approximate axial load capacity utilized by static loads is 15%, meaning 85% remains available and the seismic risk penalty points are 19 out of 100, which is considered a strong result, reflected with a green box. Before we grow upward, we must look beneath our feet. Every thriving rooftop begins with a structure that's ready to support change. Understanding a building's structural limits isn't just a technical step, it's the foundation for safe, sustainable, and visionary urban farming. Have you ever considered how much weight your roof can really hold before turning it green? Get your building's information in our tool and answer this question as a first step towards initiating your green rooftop project. To explore more about the project, please visit our website, or connect with us through our social media channels on Facebook, LinkedIn, and YouTube. Thank you for watching, and we hope this content supports your learning journey in ecologically and economically sustainable urban agriculture.